our last video, we took a look at some simple two-dimensional array methods, and I want to continue that thought. So this time, I want to write a method that determines does a particular column returns true if given column contains the given value. How about that? So public static, it's going to be Boolean because I'm returning a true or false value. I'll call it call contains, since it's determining if a particular column contains a particular value. Again, I'm going to stick with a two-dimensional array of integers, but of course there's many things we could have two-dimensional arrays of. I'll call my two-dimensional array G, and I'm taking in a particular column and a particular value which I'm out of room for, so we'll just do this. Particular value. So I want to know, does this column contain that value? And again, I'm using the convention that my first coordinate is the row number and the second coordinate is the column number. So how do I determine if that column contains the value? Right, let's go look at a picture again. I want to determine, for example, does column 2 contain the value 7? And here we should return false. That means I need to look at all of the values in this column. Potentially, maybe I find a 7 in the first cell and I can stop, but I need to loop over all the values in this column. So that means I'm really looping over all of the rows. Right? The column stays fixed, but the row number is going to increase 0, 1, 2, and so on. So let's go ahead and write that. I need to loop over all of the row numbers while the column number stays fixed. So I start at row 0, and I want to keep going until I've reached the last row. Well, the last row is g.length. Row plus plus will increase the row, and for each of those row values, we'll check, is g row column, is it equal to that particular value? If it is, well, then my column contains that value, so I should celebrate and return true. Woohoo! Here, let's make a note of that. Woo-hoo! It's very exciting we found this value. And otherwise, should point out again, this would be a bad idea right here. This says, look at the very first row in that column, and if it contains the value, celebrate with true, and otherwise, I guess boo-hoo, you didn't find it. But that's no good, because just because we don't find the value in the first cell doesn't mean doesn't exist, right? When we don't find it in this cell, we need to keep looking and try the next row and the next row, and we should only give up when we've tried every row. So, sorry, at this point, we'll return false. Now we can say boo-hoo, because we didn't find this particular value. So, we've determined, does the column contain that particular value? Not bad. Next method. Let's write a method just below that determines all columns contain. So, let's see, this one's also going to be Boolean. Ooh, you know what? Let's make it integer so we can change things up. Num calls with. How about that? And number of columns with is going to take in, again, my two-dimensional array of integers. It's going to take, well, I guess it's not going to, oh, here we go. It's going to take a particular value. So it's going to return how many columns in G contain this value. Returns number of columns in G that contain value. So how do we determine that? Let's go back to one of my pictures. If I want to know how many of these columns contain the value 7, then I'm going to determine, does the first column contain 7? If so, the answer is 1. Does the second column contain 7? In which case I might increment the number of columns. So I'm going to keep track of how many columns have that particular value, and I'm going to run this test for each of the columns. So make some more room for myself. So we're looping over each column now. For each column, starting at column 0 and going until, well, how many columns are there? Well, remember, let's go back to my picture. The column, if I want to know the number of columns, I really want to know how long is each of these sub-arrays, how long is each of the rows. So I get a particular row, and then I ask that row its length. Get a particular row, and ask for its length. Now, why did I pick 0 instead of 5? Well, there might not be a row 5. am I guaranteed there's a row 0? Well, not really. I could have a two-dimensional array that doesn't even have any rows, that's just entirely empty. But I think this problem wouldn't make sense. What would it mean to ask how many columns have a particular value if there aren't any? Maybe you could argue that the answer should be 0 then. Actually, maybe we could argue. If your two-dimensional array is entirely empty, the answer should be 0. So let's check that. If the two-dimensional array is entirely empty, there's no rows at all, then we'll return 0, since if there are no rows, there are no columns that contain this value. But at this point, I know there are rows, so it's safe for me to ask the length of a particular row and use that to loop over all my columns. Okay, for each one of these now, I'm going to call contains, because I want to know, does this column, does this column contain this value? Is that right? I took a two-dimensional array, my column number, and the value. Two-dimensional array, column, value. Yes, we got that right. Okay, now for each of these, I get back a Boolean. Does it contain that value? So if I get back true, then I found yet another column. So let's keep a count. My count should start at 0, and whenever I find a match that my column contains that value, I'll increment the count. We've seen this trick many times. And at the end, I'll return that count. So there we have it. That's the number of columns with this particular value. What else might I want to do? Let's see one where right now, it's hard to see, but we have a loop within a loop. And that's a very common thing. When we're working with, let me go back to my previous screen. When we have a one-dimensional array, we tend to write a one-dimensional, a for loop that loops over that. If we have 2 dimensions, we're going to have and we want to loop over the entire thing, we're going to have loops within loops. We're going to have nested for loops, because for each row, we might look at every column. Or actually, in this code here that we just wrote, for each column, we looked at every row. And it's a little hard to see because this method call contains is the one that loops over all the rows, and for each column, when we loop over the columns, we call contains. Let's see that all in one shot. Let's write a method where you can see those nested for loops explicitly. So let's just write something simple like add all. And this is just going to sum up all the values in my two-dimensional array. So how do I sum up all the values of my two-dimensional array? Again, I could write a helper method to add up all the values in one row, or all the values in one column, whichever way I preferred. But I think I want to see this all in one shot, because it will be useful to be helpful to see that. So for each of the rows, I'm going to look at each row. Each row. There we go. So the code I run in here is for each row. What do I need to do for each row? Let's go back to one of these pictures. Well, for each row, I need to cruise down that row and total it up. So loop down the row. How do I loop down the row? Well, as I loop down the row, the column number increases and the row number stays fixed. So the column number is going to increase starting at 0. It's going to go up to, well, let's see, how many columns do I have? I get a particular row, and I ask that row its length, and that's how many columns I have. And I'll increment the number of columns. Something to note here, I could use row 0. I'm safe using row 0 because I know there's at least one row. And I know there's at least one row because I wouldn't have entered this loop if g.length was 0. So g.length must be at least 1. There's at least one row. It's safe for me to say g0. It may not be safe for me to say g3 because it depends on how many rows I have. But it would be safe to write g0. It's also safe to write g-row. So you might prefer this. In fact, if I write g-row, then add all will work even if my array is not rectangular. If it's jagged, if some rows are longer than others, this program will still work. Okay, and we loop it over that. So for each one now, we'll get the value in that particular cell, and we'll add that to some sum that I'm keeping track of, which will start at 0. I think you've seen how to add things up in the past, so we won't get too hung up on this. Oops. So we could do a sum equals sum plus grow call, or if you prefer the Java shorthand, we could write sum plus equals grow call. And if you want to play with some Java shorthand some more, since there's only one line of code in this inner for loop, we can remove the braces. And when I'm done doing all that summing up, I'll just return that sum. So here you can explicitly see a case where for each row, I look at each column, and that way I visit every cell in my two-dimensional structure. And I think that should give you a pretty good handle on how to work with two-dimensional arrays. I'll see you in another video.